A statistician can have his head in an oven and his feet in ice, and he will say that on average he feels fine. Good day everyone! Today we will be talking about analysis of variance or Anova. Overview, Introduction, Types of Anova, Assumption of Anova, Hypothesis in Anova, Main or interaction effects, Post-hoc test, the F distribution, steps in solving Anova and application. Introduction to Anova is a statistical method used to compare the means of two or more groups. Is a collection of statistical models and their associated estimation procedures used to analyze and determine the differences among group means in a sample. Developed by statistician and evolutionary biologist Ronald Fisher. Ronald Fisher is a British statistician and geneticist. He has been described in statistics as a genius who almost single-handedly created the foundations for modern statistical science and the single most important figure in 20th century statistics. He is known as the father of modern statistics and experimental design. Here is the picture of Ronald Fisher. The next topic that we will talk about is the types of Anova. There are three types of Anova: one-way Anova, repeated measures Anova, and factorial Anova. In one-way Anova, one factor with at least two levels wherein the levels are independent. The result of one will not affect the other. This compares the means between the group you are interested in and determines whether any of those means are statistically significantly different from each other. Is an omnibus test statistics. Here is the table of the one-way Anova. Next is the repeated measures Anova. One factor with at least two levels wherein the levels are independent. The result of one will affect the other. Also referred to as a within subjects Anova or Anova for correlated samples. This has more statistical power. Here's the table for repeated measure Anova. Next is the factorial Anova. Two or more factors, each of which with at least two levels. Levels can either be independent or dependent or mixed or both. This should be used when the research question asks for the influence of two or more independent variables on one dependent variable. Here is the table for factorial Anova. The next topic that we will talk about is the assumptions of Anova. Under this topic is normality of sampling distribution of means, independence of error, absence of outliers, homogeneity of variance. Normality of sampling distribution means that distribution of sample means is normally distributed. This means that the experimental errors of your data are normally distributed. Alternative test. Sharpe-Wheels normality test. If your data is mainly unique values. The Agostino-Pearson normality test. If you have lots of repeated values. Lilliefors normality test. Means and variance are unknown. Spiegelhalter's T normality test. Powerful non-normality is due to kurtosis, but bad if skewness is responsible. Independence of error. Errors between cases are independent of one another, means that rows in your data do not influence one another. Observation may not be independent if repeated measurements are taken on the same subject. Observations are correlated in time. Observations are correlated in space. Absence of outliers. Outliers are data point on a graph or in a set of result that is very much bigger or smaller than the next nearest data point. Outlying scores have been removed from dataset, means removing unnecessary information or data. Homogeneity of variance. Homogeneity, quality or state of being the same or all different. Population variances in different levels of each independent variable are equal. Example: population is the grade 10. Sample is the 10 ZIRCON. The samples must be correlated to the levels. The next topic that we'll talk about is the hypothesis of Anova. Under this is the ANOVA with one factor, ANOVA with two factors. Noted with the Greek letter mu, factor, the independent variable. Now we'll talk about ANOVA with one factor. It's a special case of analysis of variance for one factor of interest and a generalization of the two-sample t-test. The two-sample t-test is used to decide whether two groups or level of a factor have the same mean. Example: imagine you have one factor with three levels. Your null hypotheses are equal to one another. Your alternative is that not all means are equal. It's a main effect. When you're dealing with the effect of one variable, it's called main effect. Next is the ANOVA with two factors. The idea is that there are two variables, factors, which affect the dependent variable. Each factor will have two or more levels within it, and the degrees of freedom for each factor is one less than the number of levels. Example: A and B, each with three levels. Null hypothesis for A is equal to one another. Your alternative is that not all means are equal. Null hypothesis for B is equal to one another. Your alternative is that not all means are equal. Null hypothesis, interaction absent. Alternative, interaction present. Interaction effect. The next topic that we'll talk about is the main effects in ANOVA. Example: pretend that we're comparing the test score of people who have received a medication, 100 mg dosage group, and people who have not received a medication, 0 mg dosage group. The 0 mg condition has a mean of 60, while the 100 mg condition has a mean of 80. Now, look at the graph. Interaction effects in ANOVA. Example: here we have a factorial ANOVA with two factors, dosage, 0 mg and 100 mg, and gender, men and women. In the zero dosage condition, men have a mean of 60 while women have a mean of 80. In the 100 mg dosage condition, men have a mean of 80 while women have a mean of 50. As you can see in the graph, you will see the interaction effect. The next topic that we'll talk about is the post hoc analysis in ANOVA. Post hoc, Latin, meaning after this, means to analyze the result of your experimental data. The most common post hoc tests are Boniforoni procedure, Duncan's new multiple range test, or MRT. If we reject the null hypothesis, all we know is that there is a difference somewhere among the groups. This determines where the difference lies. Are an integral part of ANOVA. ANOVA results do not identify which particular differences between pairs of mean are significant. That's why we use post hoc tests to explore differences between multiple groups' means while controlling the experiment-wise error rate. The next topic that we'll talk about is the F distribution. F equals treatment differences plus random differences over random differences. When doing an ANOVA, we calculate an F statistic which is similar to another statistic such as Z and T. If there are no treatment differences, that is, if there is no actual effect, we expect f to be greater than 1. The f statistics has its own one-tailed distribution, much like how the z and t statistics have their own separate distribution. This will be discussed and applied in the upcoming slides. P.S. If f is negative, then the computation is wrong. The next topic that we'll talk about is the steps in solving ANOVA. First, state the null hypothesis denoted by the HO. Second, set the alpha denoted by a Greek letter alpha. Third, accomplish the ANOVA table. Fourth, find the tabular value. The last, make the decision. The ANOVA table. Source of variation. Between, within, total. Sums of squares. The SSB, SSW, TSS. Degrees of freedom. DFB equals K minus 1. DFW equals N minus K. DFT equals N minus 1. Means of square. MSW equals SSB over DFB. MSW equals SSW over DFW. F distribution. F equals MSB over MSW. ANOVA formula. SSB equals summation times the square of summation xai over nai minus square of summation xi over n. TSS equals summation xi squared minus square summation xi over n. TSS equals SSB plus SSW. SSW equals TSS minus SSB, where A is a given factor or category, I is the individual observation of cell, N is the sample size, K number of columns, and X is the observable value. Application of ANOVA. You will be given 3 examples. Have your scientific calculator, paper, and presence of mind ready. Example number 1. Determine who among the 3 salesmen will likely be promoted based on their monthly sales in pesos. Use alpha 5%. Given. First, state the null hypothesis. There is no significant difference among the 3 salesmen. Second, set the alpha 5%. Third, add 3 more tables for the squares of A, B, and C. Then compute. Here is the table. Note, all computations will not be shown, for it will be done in the scientific calculator. Fourth, find the summation of A, B, and C. Fifth, find the summation of squares A, B, and C. Summation means to add all the certain values being asked. So, the summation of A is 1,300, summation of B 1,291, and summation of C 1,285. The summation of A squared is 195,122. Summation of B squared 189,243. And the summation of C squared 185,613. Sixth, accomplish the ANOVA table. 7. Compute the sum of squares. To accomplish the table, you must first use the formulae in order to solve. A. Solve for SSB. So here is the formula for SSB. After the formula, you will substitute it with the following value. After substituting it, you will solve it and then you will get the result. Remember, NAI equals number of given rows and given columns times given rows. For the final answer, 2 decimal places will do. B. Solve for TSS. In order to get SSW, you must solve for TSS first. Here is the formula for TSS. Then, you will substitute it with the following value, and you will get the answer. C. Solve for SSW. Now that you have SSB and TSS, you can now solve for SSW. Here is the formula for SSW. Then, you will substitute it with the following value, and you will get the answer. Now, here are the sum of squares. Now that you have your sum of squares completed, you can now fill in the first division of your Anova table. Now that you have your sum of square division completed, you may now proceed on computing the degrees of freedom division. 8. Compute the degrees of freedom. So as you can see in the table, you can now fill it in. K is the number of given columns and number of given columns times number of given rows. Now that you have your degrees of freedom completed, you may now proceed computing the mean of the squares division. Note, DFB and DFW will be used in the F distribution. 9. Compute the mean of squares. A. Solve for MSB. B. Solve for MSW. As you can see, there are formula for MSB and MSW. After you substitute its value, you will now compute it and will have the answer. Now that you have your mean square division filled, you may now proceed computing for the F distribution. 9. Compute the F distribution. Here is the formula for the F distribution. After you substitute the value, you will get the answer. In writing the F distribution, put the DFB and the DFW after the letter F and enclose it with parentheses. DFB, column, DFW, row. Remember that if your F is negative, then you must recompute. Now look at the table. It is all complete. Find the tabular value. Alpha is 5%. Then make the decision. To find the tabular value, refer to DFB and DFW. The intersection of the row and column in this case is 3.40, which is now will be your TV. Decision. The HO is accepted because the CV is lower than the TV. There's no significant difference between the three salesmen. For the TV, prepare your table of values ahead both for 1% and 5%. Be careful also of the alpha that is set. If CV is higher, then the HO is rejected. If CV is lower, then the HO is accepted. Icebreaker. Did you know that in a room of 23 people, 50% have the same birthday? It's called the birthday problem and happens every time. The great father of math, Pythagoras, used little rocks to represent equations, numbers, hence calculus, which is the ancient Greek word meaning pebbles. The word fraction derives from Latino fracto, to break. The symbol for division is called an obolus. If you folded a piece of paper in half 103 times, it will be the thickest of the observable universe. So now we will go to the example number 2. So you will be solving this with the given Montessori daycare preschool. First, you need to do the steps. State the HO. There is no significant difference among the 3 schools. Second, set the A 5%. Third, add 3 more tables for the squares of M, D, and P, and then compute. Note, all computation will not be shown, for it will be done in the scientific calculator. Alpha by default is always 5%. Fourth, find the summation of M, D, and P. And also find the summation of squares M, D, and P. So as you can see in the table, you will have the answer. Summation means to add all the certain values being asked. 6. Accomplish the Anova table. 7. Compute the sum of squares. To accomplish the table, you must first use the formula in order to solve. Solve for SSB. There are formula, and then you will substitute the formula, the given values, then compute, and then solve. And now we will be having the answer for SSB, which is 54. Remember that NAI is the number of given rows, and is a given column times given row. For the final answer, 2 decimal places will do. Next is to solve for TSS. In order to get SSW, you must solve for TSS first. Now you will have the formula for TSS, and then you will substitute it and compute, and we'll have the answer for TSS, which is 80.57. Then now, you can solve the SSW since you have the SSB and the TSS. You can see the formula for the SSW, and now you gotta substitute it and compute, and we'll have the answer. Now that you have your sum of square division completed, you may now proceed on computing the degrees of freedom division. 8. Compute the degrees of freedom. As you can see, it's just the same as the last example, because you're just gonna use the formula and substitute it, and you'll have the answer. Always remember that K is number of given columns, and number of given columns times number of given rows. Now that you have your degrees of freedom completed, you may now proceed computing the means of squares division. Note, DFB and DFW will be used in the F distribution. Compute the mean of squares. First, you need to solve for MSP, and then solve for MSW. As you can see, you have the formula for MSB and MSW, which you will substitute the value, and you will compute, and then you will have the answer. Now that you have your mean of square division filled in, you may now proceed computing for the F distribution. Compute the F distribution. For F distribution, you will be needing the MSB and the MSW, and you will compute it by substituting the value, and you will have the answer. In writing the F distribution, put the DFB and the DFW after the letter F, and enclose it with parentheses. DFB equals column, DFW is the row. Remember that if your F is negative, then you must compute. So as you can see, your tables are all filled. So now we're gonna find the tabular value, which is 5%. Since 5% is the default, if it's not given. Then make the decision. To find a tabular value, refer to DFB and DFW. The intersection of the row and column in this case is 3.55, which will now be your TV. So the decision. HO is rejected because the CV is higher than the TV. There is no significant difference between the three schools. Remember, for the TV, prepare your table of values ahead both for 1% and 5%. Be careful also for the alpha that is set. If CV is higher, then the HO is rejected. If CV is lower, then the HO is accepted. Icebreaker! Belfigore's prime is a prime number that is also a palindrome. It is named after the Prince of Health for ingenious inventions because it contains two sets of 13 zeros with 666 in the center. The palindromic prime number is... Yes! Did you know? A narcissistic number is a number that is the sum of its own digit, each raised to the power of the number of digits. Trigonometry was invented by Muslim mathematicians as a way for worshippers to calculate the direction to Mecca for prayer. 7393933 is the largest known prime number that, if you keep removing digits from the right, will always leave a prime number. A mathematician named George Dantzig solved two of the most famous problems of statistics because he came into class too late to hear that they were supposed to be unsolvable. So, here you can see the picture like a meme. Why are Jews angles so depressed? Because they're never right. Ah! So now we'll go to example number 3. Given work styles, attitude, productivity. So again, we need to state the HO first, then set the alpha. Since there's no given alpha, then 5% will be the default. Add 3 more tables for the squares of W, A, and P. Then compute. After computing, find the summation of W, A, and P. Then, find the summation of squares W, A, and P. Then, after that, we will accomplish the Anova table. Then, compute the sum of squares. So, to accomplish the table, you must first use the formula in order to solve. First, we need to solve for SST. We'll be using the formula, then substituting it with the value, and then computing it to get the answer, which is 0.19. Next is, we will solve for the TSS. In order to get SSW, we must solve first the TSS. As you can see, we will be using again the formula of TSS, and we will substitute it with the given value, and then we will solve it to get the answer, which is 10.38. After that, we will now solve for SSW. Since we have already the SSB and the TSS, we will be using it to solve for the SSW. Now we'll have the formula of the SSW, which will be substituted with the given value, and we will compute it to have the answer, which is 10.19. Now, we are already finished with the sum of squares. We'll go now to the degrees of freedom. We will now compute the degrees of freedom. Again, we will be using the formula of DFB, which is k minus 1, DFW, which is n minus k,
DFB, which is n-1, where we will have the answer for DFB is equals to DFW is equals to 27, DFT is equals to 29. So now we are done with the degrees of freedom. Now we'll go to the means of square. Now we'll compute the means of square. First, we need to solve for MSP, then solve for MSW. As you can see here, we have the formula for the MSP and the MSW, which we will substitute it with the following value and compute it to have the answer, which is for MSB we have 0.10 and the MSW we have 0.38. Now we compute it, and now we are finished with the table for the mean of square. So now we're gonna proceed to the F distribution. So we're gonna compute the F distribution. To compute it, we need to use the following formula, which is the MSB over MSW. Then substitute it with the following value and we'll compute it, and we'll have the answer, which is 0.26. And now we're done with the F distribution. Always remember that in writing the F distribution, put the DFB and the DFW after the letter F and enclose it with parentheses. DFB is equals to column, DFW is row. Remember that if your F is negative, then you must recompute. Then you need to find the tabular value, which is 5%. Make the decision. So, to find the TV, refer to the DFB and the DFW, which you computed before. The intersection of the row and column in this case is 2.35, which will now be your TV. So, now we'll go to decision. The HO is accepted because the CV is lower than the TV. There is no significant difference between work styles, attitudes, and productivity. So always remember that for the TV, prepare your table of values ahead both for 1% and 5% because you really need them. Second is be careful also of the alpha that is set. Don't be careless. Next, need to remember is that if CV is higher, then the HO is rejected. But if the CV is lower, then the HO is accepted. So we have more examples. We have the given schools, and now we will let you solve it. But we will give you guide steps. So we have the guide steps, which is first, state the null hypothesis. Second, set the alpha denoted by the Greek word alpha. Next, accomplish the Anova table, which will be doing the sum of squares, degrees of freedom, means of squares, and F distribution. Then we need to find the tabular value and make the decision. That's all. Thank you for watching. Acknowledgement. slidesgo.org. Stats Lecture on YouTube. Sir Aljan Lozano, Math Enrichment Advisor. Presentation by Angeli Tagaan. Voiceover, Julian Krisha Astronomo. Video Editor, Ambrose Jerome Mangit. I hope you enjoyed this video. Bye!